Okay, what I'm going to do here is show you how to do the problems from our review section, the I can start part problems. These are the ones that will, if you can do these, you'll do pretty well in the test here. So we're going to look at these. First problem asks us to simplify an expression with negative exponents. We have to deal with these negative exponents. So first thing we're going to do is rewrite this expression. Let me get this here. What we're going to do is anything with a negative exponent, we're going to move it from top to bottom or from bottom to top. So the top 4 has a positive exponent, so I write it on top. X to the negative third becomes x to the positive third on the bottom. Y to the second stays on top. 10 is a positive exponent, stays on the bottom. A negative exponent moves from the bottom to the top, so that becomes x to the sixth up here. Negative exponent here moves up top, so y to the third. And now there's no negative exponent, so I'm ready to put my answer in here. So what I'm going to do is reduce 4 over 10 to be 2 over 5. And now x's, there's 6 x's on top and 3 on the bottom, so there's extras on top. In fact, there's 3 extras on top, so x to the third. And then y's, there's 2 y's and 3 y's all on top, so combined to be 5 y's, or y to the fifth, and then that's the final answer we're looking for here. Now the next problem asks us to solve this equation here. Now there are a couple of ways to do this. First of all, what we want to do in the long way to solve this is to get the square root by itself. So before I do anything, I have to subtract 4 from both sides. So that becomes the square root of x minus 2 equals x minus 4. Then to get rid of the square root sign, what we're going to do is square both sides. So I'm going to square this side, and remember we square it like this. So the square root of the square goes away. We got x minus 2 equals, when we square this, it becomes x squared minus 8x plus 16. We do FOIL. We would somewhere on the side of the paper do x minus 4 times x minus 4. I'm not going to go through the steps. That's what that equals. Then the steps would be to get, since it's a quadratic equation, you have to get one side equal to 0. So what I'll do is I'm going to subtract x from both sides, and then I'm going to add 2 to both sides, and then these guys are going to cancel, and I'm going to get 0 equals, and then this is going to be x squared. I forgot to add 2. X squared minus 9x plus 18 equals 0. So this is going to be 0 equals, when we do this, we're going to look at this and have x and x. Look for two numbers that multiply to 18 and add to 9. That's going to be 6 and 3. And they're both negative. So to solve this, I say x minus 6 equals 0, which means x equals 6. And x plus 3, let's get back and do it right. X minus 3 equals 0, x equals 3. So 6 and 3 would be our solutions. But before we write those as our answers, we need to check to make sure they work. So let's check 6. Check 6. So that's going to be square root of, I'm going to change the color here, 6 minus 2 plus 4 equals 6. So basically I changed both of the x's to 6. That's the square root of 4 plus 4 equals 6. That's 2 plus 4 equals 6. That's true, so 6 is one solution. Now when I check 3 in here, I'm going to have, let's go back to green, square root of 3, that's a 3, minus 2 plus 4 equals, let's do this and go 3. Oh, it should be red, sorry. And then we see if this works. And what this gives is square root of 1 plus 4 equals 3. 1 plus 4 equals 3, and that's not true, so this is not a solution. So 6 is the only solution. On a test, if you have multiple choice, I would suggest not even bother with all this if it's multiple choice and just plug the numbers in. But if it's not multiple choice, you need to go through these steps. Okay, here we're going to simplify this expression so it involves just some factoring, really. So we're going to factor this thing. So I do this. I'm looking for two numbers that multiply to 12 and subtract to 4. That's going to be 6 and 2. Bigger number gets this sign here, so that's minus and that's plus. X squared minus 4, we should see that immediately as x plus 2, x minus 2. When we divide a fraction, that's the same as flipping it upside down and multiplying. So that's going to be times 2 minus x on top, and this on the bottom, which we factor that to be 3 parentheses x squared minus 6. Okay. Oh boy, okay, this is a little different than I expected. There was supposed to be an x here, I think. That's the problem. So in this one, we factor this. A few things are going to cancel. Let's see what we can cancel. We can cancel x plus 2 and x plus 2. Now these two here are not going to cancel directly, but when they're opposites like this, they do cancel, and it becomes negative 1 in front. So the answer to this would be negative parentheses x minus 6 over 3 parentheses x squared minus 6. I think this was done when I made this problem. This was supposed to have been an x, which would have made it different, but it isn't, so that's what it is. Okay, next problem here. Simplifying here, we have two fractions with non-common denominators, so we have to get common denominators. So what I'm going to do is, basically, I have to multiply. The common denominator is going to be x plus 2 times x plus 1. So this needs an x plus 1. So I do this. And this needs an x plus 2. Like this. And then so now the top of this becomes x squared plus x over x plus 1, x plus 2. Minus, and this is going to be 5x plus 10 over x plus 1, x plus 2. And now the denominators are the same, so I combine the top. Now be careful when you combine the top. That becomes x squared plus x minus 5x. Now I'm going to put minus 10 because this minus goes to both the 5x and the 10 over x plus 1, x plus 2. And now the top becomes x squared minus 4x minus 10 over x minus 1, x plus 2. We'll just leave that as our final answer right there. Okay, let's go to the next one here. We've got to solve an absolute value equation. Similar to the square roots equation, we have to isolate the absolute value. So the first step is going to be to subtract 5 from both sides. So I have the absolute value of 2x minus 3 equals 13. Now when I have an first I do this, now I write two equations. To get rid of an absolute value sign, we write two equations. One just as it is, like this, and the other one, 2x minus 3 equals negative 13. And now to solve this one, I'm going to go through the steps of solving that, and that's going to be add 3. 2x equals 16, x equals 8, and over here I'm going to add 3, 2x equals negative 10, x equals negative 5. So those are two solutions, but before I go on to circle them for my final answer, I make sure they work. I'm just going to do it up here. If we put in 8, that's 2 times 8, which is 16 minus 3. Absolute value of 16 minus 3 is the absolute value of 13. 13 plus 5 is 18. And that works. So 8 is the solution. Now I'm going to go ahead and try negative 5. 2 times negative 5 is negative 10. Negative 10 minus 3 is negative 13. Absolute value is positive 13. So 5 works. Negative 5 works also. So there's two solutions. Again, if it's a multiple choice test, my suggestion from the very start, just plug in the numbers and see what works. Okay, this is an absolute value inequality. It's similar. We have to isolate the absolute value, so I'm going to add 2 to both sides. So I have the absolute value of x minus 3 is greater than 9. And now I'm going to write 2 inequalities. First one is going to be just as it is, and the other one's going to be x minus 3. Change the direction of the arrow and the sign of the number. So that, then I'm going to add 3 to both sides. X is greater than 12, and then add 3 to both sides. X is less than negative 6. So basically it's going to be or. So that would be your answer if that's how we write it. Basically, no, that's enough right there. That's it. Okay, let's go to the next problem. This looks a lot more complicated than it really is. We're just going to simplify an expression involving multiple, what they call complex fractions. So what I'm going to do is treat the top separately from the bottom. So let's just do the top. So that's going to be 3 over x plus 2 over x plus 1. And now what's missing here is that this fraction needs an x plus 1. So I'm going to say x plus 1 over x plus 1. And this fraction needs an x, so I'm going to say x over x. So now the top becomes 3x plus 3 over x parentheses x plus 1 plus 2x over x parentheses x plus 1. And that becomes 5x plus 3 over x parentheses x plus 1. And the bottom fraction now, I'll do that in blue, that's going to be x plus 2 over x parentheses x plus 1 plus 5 over x. The common denominator is all here, x parentheses x plus 1. This just needs an x plus 1. So I'm going to go back to here and I'm going to say x plus 1 over x plus 1. And that becomes x plus 2 over x parentheses x plus 1 plus 5x plus 5 over x parentheses x plus 1. So the bottom fraction now becomes x plus 5x is 6x and plus 7 over x parentheses x plus 1. So now this is dividing fractions. So remember, when we divide fractions, we flip the bottom fraction upside down and multiply. So it becomes 5x plus 3 over x parentheses x plus 1 times, flip this upside down, x parentheses x plus 1 over 6x plus 7. And now these cancel out, and then my answer is going to be 5x plus 3 over 6x plus 7. Okay, let's move on a little bit. And for this problem, we're going to multiply, basically we just go through our method of FOIL. So 5 times 2, that's 10. 5 times square root of 3 is plus 5 square root of 3. And now I'm going to go this way. Square root of 3 times 2 is plus 2 square root of 3. Square root of 3 times square root of 3 is just 3, plus 3. So when I combine that together, I get 13 plus 7 square root of 3, and that's the final answer I'm looking for here. All right, next problem. Simplifying with i's. Now, I to the 7th, here's what we want to do. I to the 7th and I to the 20th. We got to figure out what they are in terms of I. So here's the deal. We kind of have to know this, that I to the 1st equals I to the 2nd is negative 1, I to the 3rd is negative I, and I to the 4th is positive 1. So this becomes 3. Now I to the 7th, what we do is look for basically every 4th I starts over again. So what I would do is I say 7 divided by 4. Okay, is 1 with 3 left over, so this is the same as I to the 3rd. which becomes 3 times I to the third is negative I. And then I to the 20th, there's the remainder 0, so that just becomes 1, so it's going to be minus 5. Minus 5 times 1. So that's going to be minus 5. So to simplify this, we would always put the real part first, negative 5 minus 3i, and that would be the answer we're looking for the final answer to that one. All right, we're moving through it. Now here we have some issues here. 2 plus I over 5 minus I. We don't want i's in the denominator. So what we need to do is use the conjugate, which is going to be 5 plus I. And we have to multiply top and bottom by the same conjugate. Now remember the conjugate is just the same thing with the change of the middle sign. So now the top of the fraction becomes 10. That's 2 times 5. Then we go 2 times I is plus 2i. And I times 5 is plus 5i. And then plus I squared. And then the bottom is going to be 25. And then it's going to be plus 5i. And then it's going to be minus 5i. And then it's going to be minus I squared. So now we're going to simplify this. So it's going to be the top will be 10 plus 7i. Now I squared is negative 1, so that's going to be minus 1. And the bottom is going to, which I can simplify, I guess, to be 9 plus 7i. And the bottom is going to be 25. 5i minus 5i cancel. And I get minus I squared, which is minus negative 1. So that's minus negative 1, which is plus 1, so that becomes 26, and that's the final answer we're looking for right there. Okay, next problem, we're going to move on. This is a square root, actually a fourth root. What we want to do with this one is simplify 32, so 32 is broken down to be 4 times 8, which is 2 times 2, and this is going to be 2 times 4. And 2 times 2, so it's 2 times 2 times 2 times 2 times 2. So this whole thing here is going to be the fourth root. 2 times 2 times 2 times 2 times 2, 5 2's. 6 x's, 1, 2, 3, 4, 5, 6, and 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. And now what we're going to go through is circle groups of, in this case, groups of 4. If this were a 3, we circle groups of 3. If it were a 5, we circle groups of 5. If it were a 2, we circle groups of 2. This is a 4, so circle groups of 4. There's 4 together right here. There's 4 together right here. And there's 4 together right here. And there's still 4 together here. So now each circled group, essentially we can think of canceling out 3 of them and bringing the other one out in front. So that's going to be 2 out in front. Same thing here. X, same thing here. Same thing here. And what's left is what's not canceled out is 2 times x times x. And then we just want to simplify this. That's going to be 2xy squared, the fourth root of 2x squared. And that would be the final answer to this problem. Okay, we're going to move forward again. Okay, this one they want us to solve, but they want us to solve it by completing the square. That's the method we would use for this one. So the first step is going to be to get rid of 5. So that's going to be x squared minus 8x equals negative 5. And on the test, what they're going to ask is, they're going to show us one of the steps. So we have to kind of go like this and see if any of these, if this was one of our 4 answers. And it's, I don't know if it will be, but probably not. Now we've got to figure out what goes here, which is going to be half of this number squared. So x squared minus 8x, half of 8 is 4. 4 squared is 16, so plus 16 equals negative 5 plus 16. So that's the next step. Then this becomes x minus 4 squared. Half of this number is what goes here. And this becomes 11. So now we take the square root of both sides. So we take the square root of this side and the square root of this side as a plus or minus. This disappears, so now we got x minus 4 equals plus or minus the square root of 11. Add 4 to both sides. X equals 4 plus or minus the square root of 11, and that would be the final answer we're looking for. But they probably, on a test, they're going to show you one of these steps along the way. Now, it works easy to figure out this number here. That's always the tricky part. It's going to be half of this number squared. Now, if this number is let's say it's a number like 9, then it would be 9 over 2 squared. So I would say 9 over 2 squared if that were 9. So for instance, if I had a problem like this, x squared plus 9x equals 10 or something like that, and I want to know what goes here, I would say half of this number is 9 over 2. And then 9 over 2 squared is going to be 81 over 4. So sometimes the numbers are really tricky what we put here. We just have to take half of the square. So if this is an even number, it's pretty simple. Odd numbers are a little tricky. All right, next problem here. What are the nature of the solutions? What they're looking for is the discriminant, which is b squared minus 4ac. And what happens is if that's, we just look at that itself. Now there's 4 possibilities. We can be positive and a perfect square. That's going to give you one type of answer. It can be positive and not a perfect square. It can be 0, or it can be negative, and that's what we look for. So just the b squared minus 4ac part. So if it's positive and a perfect square, then the nature of the solutions are 2 real rational. Sometimes they use the word unequal instead of 2. For not a perfect square, we have 2 irrational, 2 real, they're still real, and irrational. Again, sometimes instead of 2, they're going to write unequal. If it's 0, we have 1 real and rational. Sometimes they, instead of saying 1, they're just going to say equal. 2 equal roots, because basically with the second power function, we generally have 2. We say that we have 2 roots. It's just that they happen to be equal, which means there basically is only 1. If it's negative, we have 2 imaginary roots. And that's all we need to know. So for this problem, we're going to figure out b squared minus 4ac, which is negative 12 squared minus 4 times 9, which equals 144 minus 144, which equals 0. So the answer is, for this problem, is going to be 1 real rational root, or 2 equal roots. Okay, let's move on here. Find the sum and product. We have to go through the formula that we learned earlier, which said the sum is equal to negative b over a, and the product is equal to c over a. So now we have this. Some people just remembered negative BACA, B-A-C-A. So the sum for this problem would be negative b is negative 12, so negative 12 over 4, which is negative times a negative is positive. 12 over 4 is 3. That's the answer to the first part. That's the sum. And the product is 25c over a, and that's the answer to the product. So that's a pretty easy problem if we know how to do it. Okay, next problem here. Determine if the relation of the function is is a function, first of all. Is it a function, yes or no? We look at just the x values. And since they're all different, it's a function. Yes. Is it a one-to-one function? A one-to-one function, all the rules that apply to the x's also apply to the y's. So while the x's, it is a function, but one-to-one function, we're going to look at the y values, which are 5, and so these 5s repeat each other, so that's not a one-to-one function. So depending on what's being asked of you, it depends on whether they're asking you. If it just says, is it a function? Yes, it's a function. Is it a one-to-one function? No, it's not. Okay. Now that method's with letters. With ordered pairs. Now we're going to look at it with equations. The rule for a function is it must have a y value, no absolute values. So it can't have a y squared, absolute value of y, and no, what they say, even powers. No absolute value of y. No even powers of y. So basically y squared, y to the fourth. If it has any of those, it's not a function. So I look at this and say, does it have any of those? This is a square root. That's okay. It just can't have an even power. So that's perfect. So yes, a function. Now to determine if it's a one-to-one function, all the rules have to apply for the y's. Also must apply for the x's. But since I see an x squared, it's not a one-to-one function. Basically, one-to-one just means the rules that apply to one variable apply to both variables. So that's that. Now we're going to look at a couple more. This is with an equation. When we do the equation one, typically what we're doing, we look at what we call the vertical line test. So let's draw a vertical line here. This will work. That's not a vertical line. Let's draw a better one. I think that's a vertical line. So what we're going to do is take this vertical line and drag it across until if it ever hit the graph twice, it's not a function. So this would be a function. And over here, when do I ever hit the graph twice? And the answer is here. It looks like I do, but the top one's open. So this is still a function. So for both of these, we have functions. So this is a function, and so is this. Now to check if it's a one-to-one function, we do the same thing, but in the horizontal direction. So now we're going to check to see if that same thing works here. And here we hit the graph at two places, so not a one-to-one function. Over here, whenever you have a horizontal line, that's not a function. Not a one-to-one function, sorry. So it's not one-to-one. Now don't get confused. So far every problem we've done has been a function but not a one-to-one. I just happen to work them out that way. Those are we have to check each method. Okay, next problem. Find the inverse. The inverse, this shouldn't be here by the way. We switch the x's and the y's. Now this technically is y equals 4x plus minus 3. We need to switch the x and the y, so that becomes x equals 4y minus 3. And now to figure this one out, we solve for y. So to go to the steps that we've learned in 8th grade to solve for y, we're going to add 3 to both sides. And then what that becomes is x plus 3 equals 4y. And then the final step would be to divide by 4. Divide by 4 and these cancel, so I got y equals x plus 3 over 4. And that's the final answer there. Okay, the next problem, we're going to keep going here. F of these, this shouldn't be here either. Okay, for any of these. So the first thing we're going to do, g of f of 5. Excuse me, negative 5. So the first thing I want to do is figure out what f of negative 5 is. So over on the side, I say f of negative 5. And that means I go to function f, replace the x with negative 5. So it's 2 times negative 5 minus 3, which is negative 10 minus 3, which is negative 13. So f of negative 5 equals negative 13. So this right here, this part right here is the same thing as negative 13. So I have g of negative 13, which means I go to function g, replace the x with negative 13. negative 13 parentheses squared plus 1. Now, if you're doing this in a calculator, make sure to put parentheses around negative 13, otherwise your answer will not work. So that's going to be 169 plus 1, which is 170. So that's the answer we're looking for that problem. Okay, now as we move on, now we're going to find the same thing. We're going to find f of g of x. Now the problem with this one is it's a little different. The one before we had negative 5 as a number. Here we don't have a number. So we take this whole thing. That just becomes f of, instead of g of x, I'm going to write x squared plus 1, because that's what g of x is. This isn't here. So then this becomes, I go to function f and replace the x with this whole thing here. So it's 2 parentheses x squared plus 1, or, I didn't finish, sorry about that. Hold on a second, I haven't finished that equation. That's, x has become this, and I put minus 3. And that becomes 2x squared plus 2 minus 3, which is 2x squared minus 1. And that's going to be my final answer to that problem. Okay, we're winding down. Let's get through this here. And the maximum point of this. The maximum point of the graph, we don't know what the graph looks like. We do know the maximum point is at negative 3.8. If I wanted to draw a picture of what that looks like, I can draw, oops, that's not very good. Let's draw straight up and down. I can draw a graph that looks something like this. So somewhere over here, negative 3.8, that's where my point is going to be. Somewhere up here, negative 3.8. That's the maximum point. I don't know what the graph looks like. It has some weird thing, but that's the highest point. And we're going to shift the graph a certain direction. Now, here's the deal. When the number inside with the x tells me I'm going to shift it left or right, and I go the opposite direction. So that means I'm going to go to the right 4, because negative is left. I go the opposite direction for the x. But I go the same direction here in the vertical direction for the y. And then so I go right 4 and then down 5. So to the right 4, 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. So I can look at the thing. Basically what I'm going to do is I'm going to add 4 to negative 3, and I'm going to get 1. And then I'm going to subtract 5 from 8 and get 3, and that would be my final answer. Using the graph kind of helps a little bit, but the idea is the same. Okay, let's move on now. We're looking for growth or decay. These problems look complicated. They're really fairly simple. We look at what's being raised to the power, and that's 1.2. If this is bigger than 1, it is. That's a growth. If the number being raised to the power is less than 1, it's a decay. We don't even concern ourselves with this number. So I look at this number is 0.95 when I look, because the whole parentheses is being raised to the power. That's x. Okay, 4 has nothing to do with the problem. This number is less than 1, so it's a decay. And that's that. Okay, as we move on, we're looking at this problem, and we say b equals 300 times 0.8 to the t power. Tell whether the model represents exponential growth or decay. This number here is less than 1. That means it's decay. The next thing says identify the percent increase or decrease. We know, well, it's a decrease because it's a decay. But how much, what percent would that be? If I can think about that, to come up with this number, I had to do 1 minus 0.2 to the t power. So 0.2 is the decay. As a percent, that's 20%. So it's 20% decay. Okay. If this were bigger than 1, then it would be growth, but the same idea. I'd compare it to 1. So that would be whatever that number is here is my percent decay or growth. Now, generally, we might ask a problem, what is the value after 5 years? Then we just make the t of 5 and plug it into our calculator. All right, this one here. For this problem, we're going to use this formula, and P stands for the principal, which is $10,000. R is the interest rate, which is 5%, but I have to write that as a decimal, 0.05. Move the decimal 2 places. Right here is where it is, 1, 2. I need a 0. And then compounded monthly means 12 times a year, so n equals 12. And then t is the number of years, in this case 40. So the equation would be A equals 10,000, parentheses, 1 plus 0.05 over 12 to the power of 12 times 40. Now when you're putting this in your calculator, it's really important to keep this part in parentheses. If you close parentheses here, like if you're doing 12 times 40, a lot of people put that as 12 times 40, which is fine, but if I'm raising something to a power here, 1.01 or something like that, and I do this in my calculator, but this closed parentheses is going to stop the exponent. So don't do this. Just do this and put the times button in the middle. And then the answer to that, what number is that one going to be? Is going to be 70. Let me write the answer to that. When I put it in, I get an answer. Where's my thing? Come on. Right here. So I get an answer of $73,584.17. All right. We're winding this down here. That's not too bad. Now we've got more calculator stuff for the next one. It's a little easier because there's not as many things. There's no n in here. We're doing it continuously. So A equals P, that's going to be 8,000, times e to the power of RT. R is 0.065 times t, which is 18. So when you do this in your calculator, you type in 8,000, and then you do second ln, which gives you, when you do this in your calculator, you're going to get this, and it's going to look like this. So without parentheses are already there, I don't need to add any more. I just put 0.065 times 18. And when I do that, I get the answer of 25,000. Let me see what higher. That's going to be $25,775.94. Okay. And that's the answer to that. Almost done, guys. Let's go through the next one here. Solve for x. For these problems, we want to get the common base. So this is going to be 2 to the third to the 3x minus 2. And this is going to be 2 to the fifth to the 2x plus 1. All I did was change 32 to look like this and change 8 to look like this. And the rules tell me now I multiply exponents. So I have 2 to the 9x minus 6 equals 2 to the 10x plus 5. And now since the bases are the same, I can essentially cross off these bases because the exponents have to be the same. So 9x minus 6 has to equal 10x minus plus 5. Now to solve this, I'm going to subtract 9x from both sides. And I got negative 6 equals x plus 5. Subtract 5, x equals negative 11, and that would be my answer to that problem. Okay, I know I'm kind of quick, but I'm moving through. Write this in logarithm form. We have to be able to just work back and forth. Log, the base goes down here, and this is the base, 3. The answer goes right here, and the exponent goes over here. And I check to make sure 3 to the x equals y. That's perfect. That's the answer there. Now we're going to go backwards. This is very quickly. W to the negative 9 equals 512. W to the negative 9 equals 512. That's all we need. If they ask us to solve, we got another step. They don't ask us to solve. If they did, we would raise both sides to the negative 1/9 power. But we're not doing that. So, and the answer would be negative 1/2, by the way. Here we want to solve for x. The method here for solving for x is to get rid of this, well, to get exponents that are variables out of the exponent. We're going to take the log of both sides. Log of 5 to the x and log of 40. So now this x comes in front, so x times the log of 5 equals the log of 40. So now I can divide both sides by log 5 because log 5 is just a number. And that's what I get there, and these cancel. So I get x equals, and then I go to my calculator and I put log 40 divided by log 5, and I get x equals 2.292, somewhere around there. So that should be the answer there. Let's round it off. A couple more problems and then we're done. This one here is a little trickier because we have this 1,000. Before we take the log of both sides, let's get rid of this 1,000. So I'm going to divide both sides by 1,000. These are going to cancel, and over here 1,000, and I got 2.5 equals 1.075 to the power of 4x. And now I take the log of both sides. And you can do natural log if you want, but I'll do log for this one. Either one works. So I do log of this, and then that becomes log of 2.5 equals, and this 4x can come out in front, 4x times the log of 1.075. And now I just go through my math again. I'm going to divide both sides by log 1.075, and divide this by log 1.075. And these are going to cancel. So that leaves me with, when I do this in my calculator, I get 12.6698, something like that, equals 4x, and then I finish that by dividing by 4. Divide by 4, divide by 4. So x equals 3.167. That'll be our answer to that one. Okay, two more problems and then we're done. This one is e to the power, and there's a couple of ways to do this. You could do log of both sides. Whenever you have an e, it's kind of asking you to, it's begging you to use different logarithms. So we're going to use ln for this one. The reason we use ln, because ln of e is just 1. If I use log, it just requires more work. This t comes in front. All the rules of exponents still work with log. Ln of e equals ln of 120. But the ln of e is just 1, so I don't need to divide by ln of e because that's the same. That's just 1. So t equals the ln of 120, which is 4.787. Okay, and the next problem here, similar. First I have to get rid of this 1,000, so I divide by 1,000. These are going to cancel. So I have 5 equals e to the power of 0.05t, and I do the same thing I did before. Since I have a logarithm, I'm going to take, since it's e, I'm going to use ln of both sides, and that becomes ln of 5 equals 0.05t times the ln of e, but ln of e is just 1, so I don't worry about that. And then I'm going to divide both sides by 0.05. 0.05, not the ln of 0.0, just 0.05 without ln. So then I do ln of 5 divided by 0.05, and I get 32.1888 equals t. And that's my answer for that one. All right, we're winding down. Now we're going to do expanding and condensing. To expand, we notice there's 3 letters, so that means there's 3 logarithms. Each letter gets its own logarithm. So I'm going to put log base 3 of w squared plus log base 3 of x to the 1/2. 1/2 because that's the square root of power. And the reason it's plus is because it's on the top of the fraction. Anything on the top of the fraction is plus. Anything on the bottom of the fraction is minus. So minus log base 3 of y to the 3rd. And then the last step is to take this exponent and put it in front. So it's going to be 2 log base 3 of w plus 1/2 log base 3 of x minus 3 log base 3 of y. And that's the answer to this one right here. Okay. And the last problem here is when we're going to work backwards. Now we're going to condense. So now if you look at the last problem, we went from this step to this step to this step. Now we're just working backwards. So here we took the exponent and put it in front. We're going to now take it in front and move it back. So what happens is we take this 3 and move it up to here as an exponent. And this 4, move it up to here as an exponent. And a 1/3, move it up to here as an exponent. So I have log of x to the 3rd. Now there's no base, so I don't want to add a base. So that's it. The base is 10. That's understood. Minus log of y to the 4th plus log of z to the 1/3, which is the cube root of z. That's the way we want to write it. And then the last step is to make the single logarithm. There's no base, so I put the base is 10, so I leave it there. Anything with a positive number in front goes up top, negative number goes in the bottom. So this is a positive, so that's going to be x to the 3rd. This is a negative, so it goes on the bottom, y to the 4th. And this is a positive, cube root of z. So that's the final answer to the last problem. Now, I realize this was long. Hopefully it helped a little bit.